Hello and welcome to this Spatial Spotlight, where we will be going through what DBScan is and how we may use it to effectively cluster different phenomena on space. I am Tomas Ehrenfeld. I'm a solutions engineer at Carto. And just starting with the presentation, so we talk about a little bit on what DBScan is. DBScan is a density-based clustering algorithm. And the really cool thing about it is that it can spot any sort of arbitrary shape, any weird shape that we may have on space. So you may be familiarized with other clustering algorithms, such as k-means, which we can see at the bottom. And these type of algorithms, they need as an input for you to specify how many clusters you want to find in this space. And it will partition space so that each point belongs and is closest to the center of that group. But because we need to specify the number of groups, then weird things can happen, such as the example that we can see in the middle, or the two curved shapes. The good thing about DBScan is that given a set of parameters that we will discuss now, it can find these weird shapes effectively, and you don't need to specify how many clusters you want to find on that space. So you can find different rings, you can find different groups segmented on space, or it can struggle to find and separate points as in the last example if everything is clustered together. So what arguments do we use to leverage this algorithm? Now, this is a good thing about DBScan. It's pretty simple to use, and it only has two different inputs. We have what's called epsilon, which is the maximum distance that will be used for searching for neighbors. And we have the minimum points for a point to be considered a core cluster point. Let's look at this example and see what's happening. For example, in this case, we can see the distance epsilon by the E, which is giving us this buffer around this center point. Now, if we look in this epsilon area, we will find 4 points, so 4 neighbors. So this means that this point in the middle is a core point. Now, if we take a look at this other one, the one that says border, this one on an epsilon that we can see in purple, in an epsilon distance, it only has 2. So because this belongs to the cluster, because it's a neighbor of the core point, but it doesn't have enough neighbors, because the minimum point is 3, this will be a border point. And these DBScan algorithms also allows us to have noise to leave data outside of these clusters to see if they actually don't belong to any cluster at all. So that is everything that we need to know to see how we can use and leverage this algorithm. So let me show you how we can actually use this really easily from Carto workflows. Now, what we're seeing in here is a really quick and simple workflow where we are using some data points, which we can see here. We have only like an ID and a geometry, and we can see these points on the map. So this is some data on Barcelona, Spain. And if we take a look at this data, we can really make sense of what is going on in here. And in this case, we're seeing accidents that happened, a history of accidents. And in order to cluster this using the DBScan, it's just as simple as getting the DBScan component and configure the 2 parameters that we were describing, the search radius, which will be, in this case, 150 meters, and the minimum number of geographies that we will use to consider a point, a core point of the cluster. Now, this already, whenever we run this, we already get this cluster. And for all of the noise points, we get the value null. And we can actually see, doing a really simple group by, if we group by cluster and we count the number of IDs, we can already see all of our clusters and the number of points that are falling within these clusters. Now, the last thing that I'm doing here is just using the hex color generator so that we can color these clusters and we can visualize them. Then I'm casting the cluster as a string instead of a number. So if we see these results, these will be just the points as we had before. And if we create a map, if we click on the Create Map button, this will gives us a new builder map, and we can really quickly just visualize all these points based on their clusters. So if I color based on the cluster hex color, which we created on the workflow, just need to configure this so that we say that we want the color of the point to be defined by the hex color of the hex color column. And we can already see all of these different clusters that we have on space. And all of the gray points are noise. So this already tells us where we're having a really high concentration of these accidents. And we might want to investigate what happens on these specific places. Now, we can go ahead and rerun that workflow for a different set of parameters. But what we can also do is turn this into a query and use SQL parameters to be able to compute these clusters directly on this map and see what things we can find. So let me show you how on a pretty simple query, we can get these same results, and then we can enhance this with SQL parameters. So in this query, just a few lines of code, I will run it so you can see the results really, really quickly, only a couple of seconds. We're already calculating our the same results, right? So we have the cluster and the geometry. And what we're doing is just getting an array of different colors, 16 colors. Here we're using the cluster DBScan with the same information, the geometry, the search distance, the epsilon, and the minimum geographies. And then here in this last part, we're only doing some configuration to be able to style this better from a carton map. So let me go to our map that we had before. And let's actually toggle this layer off. Toggle this layer off. And we can add a new source in here from a SQL query. And I will just paste this here. So if I run this, I should get the same or at least similar results. I don't know if the epsilon and minimum geographies was the same. Here, we can do the same, go to this layer and decide that we want to color this based on the hex color, but we want the palette to be the hex color itself. So we put this on, and this already computes our clusters. And to visualize this better, we can select a dark base map. This is already much better. And the point size, I just decrease the point size of the null geographies. So if we make the radius based on the point size, and this is what we did on the last part of the query, and we put this to go from 1 to maybe 3. And this already gives us a much nicer visualization of our clusters. We can also add some stroke color and maybe make it a bit thinner, something like that. Now, to make this really dynamic, what we can do is we can add these SQL parameters. So to do that, we just come here to this create SQL parameter, and we want two numeric parameters. One will be our epsilon, which we want a numeric value. And let's say this distance will go from maybe 10 meters to 300 meters. The default value will be 150. And this will be a discrete value that we will be able to jump from value to value in a 10 step increment. We also want another numeric SQL parameter that will be the minimum points. And this will be something from 5 to maybe 80 in a 5. Let's make this 30 as a default value. And this will have a 5-step increment. Now, what we can do is we can go to this to the query that we written before, and we can change these fixed values for the SQL parameters that we have created before. So if I just put this in here, which I can copy from here, I can run this again, and you will see that this now is toggled on, and the clusters are being computed based on whatever the user prompts on this interface. now when we get the results, which will probably be really similar because we had the same values. But now it's much easier to do something as, okay, I want to find these DBScan clusters, but I want to be much more restrictive on the number of neighbors that these clusters needs to have. And this will probably show me fewer clusters with really high density accidents to find which are the real hotspots of this city. And I can be a bit more restrictive again, and this will gives us really high concentration points or clusters. And we can do the opposite. We can expand the epsilon, which is the search radius, and be less restrictive on the number of points. And this will probably tell us which are maybe all of the different segments, the different parts of the city. And in this case, this will probably be just like different towns or villages. But as you can see here, I can see all of the different clusters. And if I zoom out, we're much less restrictive. If we say, let's have 25 neighbors on a total distance of 300 meters, for example, you will see how this will now probably prompt me all of the different regions that I have, all of these different groups. And you will see that this can take any shape or form, which is this really cool thing about the cluster DBScan. And in here, you can see we get all of Barcelona is a single cluster on its own. Then we have this section, which is Badalona. And then we can see all of these different towns or cities, and maybe different sectors, urban areas within these towns. So hopefully this was enlightening on how you can use this cluster DBScan algorithm and how easy it can be to leverage it from Carto with these SQL parameters to be able to change how we're using these algorithms to find these spatial patterns. Thank you, and best of luck.